Hello, my fellow YouTubers. This is Roy back again. I am so excited about what I'm working on with Leedskalnin's wheel. Let's start off with how I'm getting there. This is my antenna array, I call it. I got a couple different forms of antennas up top. One's a piece of iron. You see the iron's right there. Then I have another antenna, it's a toroid with a bunch of needle points coming out. And then I have that aluminum antenna, which I don't really get a lot from, but I get more from the iron up in the air. And that's isolated too from the pole, so they're all independent. Then I also have a pole going in the ground, and then I have a underground array. I call it antenna. So coming into the building, I have this ground. Huh. Didn't realize that one, but this ground, and this is the iron antenna is split together. So that may be the reason. Because it's bipolar. So here we are. I got my voltmeter. Okay, I got my voltmeter. It's at 0. It's on DC 200 volts. Full wave bridge rectifier using germanium diodes. So we have one leg coming in from what you just seen outside, and you have the bottom leg of that coming from the ground. That's outside. Well, I'm not going to show you everything, but I'm going to show you how to light up all these LEDs and how to keep a steady voltage on the voltmeter. I got a capacitor, the voltmeter set up. I got a little electric motor I could run. I got a toroid. I got a pulse resistor and my capacitor. 100 microfarads, 35 volts. So it's not a big capacitor. And I got this right here is resistance wire from a hair blower. All right, guys, you ready for this? Let's fire in a hole. And this is all from being at it hard every day. And this energy here is free. There's no batteries. There's nothing. And like Leedskalnin, who I have sitting right here, I believe this was not just this not a generator. This was he figured out how to pulsate the ground in the air, and he was creating power in a different way. And it's this here is not going to make a lot of power, but another way of making power is what Ed came across. All right, let's go ahead and all these wires. All right, so where do we start? Let's go ahead and tap into the power. So we're going to take got my toroid over here. Trying to figure where everything goes. So here's a toroid, okay, and it's just dangling, okay. So we're gonna hook up one end over here to the resistance wire, and then the other end, I'm just gonna hang up in the air. I'll just dangle it. And I want you to That's volts popping around, guys. The angle of this toroid. Alright, so toroid's hanging. It goes to the resistance wire. The other end of the resistance wire, the voltmeter just went down to 0. The other end of the resistance wire goes to the top side of this full wave bridge rectifier, which would be the AC plus. That AC plus wire goes out, and that goes to that antenna that's split between the ground rod and between the upper apparatus. I got 17.4 volts. LED's not lit up. Let's go ahead and if I connect this to the other side of the capacitor, you're going to see the voltmeter drop. All right, let's undo this. And the voltmeter went up to 17.5. And then you come over here and it dumps out that voltage. Now it'll climb. See it climb? Now I'm going to put a load on it. Now this bank here of LEDs, it takes I think a volt and a half to 3 volts to run these LEDs. This capacitor is charging right now at 7.5 and climbing. How to use resistance wire. Remember, we started with 17.5 volts. Without the resistance here, in this is a pulse resistor, by the way. There's an oscillation that's going on here, and I'll show you why this is all happening, because there's an oscillation, but the oscillation is in my circuitry. It's pretty cool. So here's the LEDs. Here's the resistor. I'm going to touch the resistor. All the LEDs are on. Just take the resistor off. LEDs are off. Resistor on. All the LEDs are lit. Okay. So all the LEDs are lit, and now the volts in this capacitor is dropping down. Oh, hold on. My resistor just fell off. There we go. Volts should be dropping. LEDs are all lit. Every single one of these are lit. Now, we're going to grab another LED, and what I'm going to show you is what's coming from the free energy, the over unity here. So here we are at 2.9 volts, staying steady, okay? All these LEDs are lit up. Let's add more load to it, okay, guys? We're adding more load. So here's another LED. Remember, 2.9. There's another LED on, okay? Still 2.9. Let's go ahead and grab another LED. This is not easy with one hand, though. Just to let you know, guys. Here's another LED. And we'll put that on. You can see that's lit. They're all lit. And we're still at 2.9. So the way I have this circuit set up is we're pulling current from the ground and from the air. There's another LED. Uh-oh. Uh-oh. Do I see it climbing? Do I see it climbing? There's another LED, and all of a sudden it goes up. What is that? Well, hold on. LEDs are all lit. What's making it climb? I must have bumped into the wire. So, for instance, if I take off the connection, right, they'll go off. Watch, bam, LEDs are off. LEDs are on, off. The voltmeter goes up because there's energy being built in the capacitor. go a little further. All these LEDs are lit up. We're still maintaining a steady voltage in this capacitance, in this capacitor. 2.9 volts. Back to 2.9. I got a little motor here. Want to run a little motor? Let's go ahead and run a little motor. So we're going to undo that. We're going to come over here and connect one side of the voltmeter or the motor. And then we're going to connect the other side of the voltmeter. So now we're up to 5.7, 5.9. The capacitor is charging. This is from ground and air. 6.2. Let's just let that climb. Should we let it climb? Well, let's run the motor and then we'll let it climb. So here we are. Watch the motor. Ready? I got to take the resistor off. Connect that to the capacitor. The resistor stopped this motor from running, but it didn't dump the tank circuit. So there's something for me to learn a little bit more. 6.7, 6.8, 6.9, 7 volts. Now we'll come over here and we'll see if we can turn that. All right, you see that? Volts just dropped down. Now we're at 1.5 and climbing. Let's see how long it takes for it to climb. So you can see the rate that this capacitor is charging. And this is from ground and from air, guys. There's no batteries here. We got our inductor hanging like an antenna. Here it goes again. You ready? All right, you see that motor turn. Let's connect that back to the LEDs. We're at 2.7 because we just made the motor run. Look. I'm making the lights blink by connecting it like this. They are bright. They're all on, every single one of them. I haven't even counted. We're at 1.7 volts. We got all these on. So, are we going to climb? It should climb. Oh, we got to put the resistance back in. Woo, not good, not good. So did you notice that it wouldn't climb without the resistance? Now I put the resistor back in. So now we're up to 3. So it goes to show you I can drop down in more resistance here. Let's go ahead and grab some resistors. There we go. Let's just grab one. I don't even know what it is. I don't even know what the values are, but we're going to use it instead. So that one right now is at 2.9 again. So we're going to dump it. Lights are off. Go to the resistor. Go touch a resistor. Lights are back on. All of them. And we're back up to 2.9. So the resistance didn't change. But listen, if we don't get rid of the resistor and go right to the wire, we are bright, powered, and we're sitting at 1.7 volts. We'll maintain in the tank, the capacitor. But I like this one here, the pulse one, and it's like 1K ohm, and you can see the lights are all lit up, and we're sitting at, go back to 2.9, I guess, 2.9. All right, you guys, leave your comments. This is the start of the future in getting power, usable power. We've seen a motor run. We see all these